All right, folks, I'm going to go ahead and get started here. If you're in the right room, this is Successful Software Development with Cassandra. My name's Nate. I work at a company called The Last Pickle. We do work with clients to deliver and improve Apache Cassandra-based solutions. Based in New Zealand, my partner Aaron Morton, and USA here with myself in Austin, Texas, and Patricia Gorla in San Francisco. What we're gonna well, first of all, who went to trainings this week already? Who went to training yesterday? Okay, cool. So that's good stuff. Who has a project based on Cassandra in production right now? Oh, cool. So a few people. His hands get more and more every time I ask this every year. So who's got something in development they haven't put in production yet? Okay, cool. Who's getting ready to start their first project? Totally greenfield or oh, awesome. This is always my favorite. All right, so what makes a software development project successful? So it's a simple question, right? Well, kind of not, but yeah. But successful is a loaded term in a sense. Something can work, the project can work, it can be successful, but it may not be successful as a software project. I'm just going to reclip here real quick. I'm getting reclipped. Okay, cool. So the things that make software projects successful at a very high level that it ships. Like that's, what we talk about is a pretty binary thing. That means you can create something to match a set of requirements in a reasonable amount of time. And it's maintainable. It's not a hack. Use some well-known patterns where appropriate. Ooh, feedback. And what I think is most important part of that is that somebody new can figure it out. That's what we mean by maintainability. Good test coverage, of course, is really, it's straightforward, but that, it's not very often you see that and see it done right, because that goes hand in hand with being maintainable. And the last point there, checkout and build, is that you got to have it set up so everyone on your team can just pull it down, new person can just fire build, and everything works. You don't have to hand jive something. That's the ideal. That's the place where there's enough tools out there these days that you should be able to get to that point. The problem is that gets definitely harder as you add external resources, and you have to add external resources when you start talking about distributed systems like Apache Cassandra. And the whole real crux of that problem is that there's an impedance mismatch there. You're doing distributed systems development on your laptop, right? There's like components you need to run, there's stuff you need to do. It's a different beast when you start talking about a system like Cassandra when you're writing software. A real runtime is very difficult to emulate in development and testing and staging. It takes a lot of work. The good news is it's not impossible to do. It's just you have to, there's some things you have to do it right. And we're going to spend the next 30 minutes or so going over what those things are. Just as my day-to-day job, part of what I do is I get to see this firsthand all the time. I've done this wrong a bunch of times. I've done it right once or twice. So I'm trying to impart this experience onto people so they don't have to fall into the same traps. So with that in mind, let's talk about where you want to start. Because we have now multiple components that we're dealing with in our data tier, you really want to minimize complexity at any level of architecture you can. Because you need to take into account the amount of time it takes to learn a new system, so that the smaller the number of moving parts initially, the better. First off, you really want to be JVM-based, if at all possible. And the community grew up around Java. It continues to be the most common language for developers out there. There's good drivers out there for other languages, but the JVM is just where it's at. This is where most of the community traction is. And nobody's going to chase you away if you're doing Windows or something else. But Python's also okay. It's also had a good community around it since the start of the project because a lot of the tooling and testing, distributed testing, has been done in Python. D-tests, particularly, and the CQL shell is a good example of this. So if you're looking for like a dynamic typing language, that would be one to pick. C#'s coming along. They've done a lot of development there the past couple of months particularly. They just released a version of that that's supposed to be pretty close to reference implementation. I have not looked at that one in detail yet. I do see the commit messages though, and they're doing a lot of work on that. It's been some good work. Ruby's in the same boat. There's a long story there. Ruby had a fragmented sort of market from the start, and one of the major drivers for Ruby came out of Twitter, and it wasn't really maintained for a while, the past year or two, and DataStax has since taken that over and like redone as a reference implementation. I believe that just was released too within the past couple of days. C++ is almost done as well. Matt Stump gave a talk about that earlier. You can catch him in the hall and talk about that if you want to do like a really high performance C++ implementation. That should be done within the next week or two. The only thing outstanding, I think, was just the host discovery mechanisms for token aware load balancing. So that's really sort of an overview of language implementations. Best practice there would be stick with Java if you can. And with that in mind, one of the first questions that is a job builder going to ask, well, what about an ORM? I'm hesitant to recommend this unless you're doing some very basic CRUD operations. There's some, and I'll say that, and there's some really simple annotations available in the DataStax driver that make simple CRUD operations pretty straightforward. There should be something to look into if you're into that type of thing. But just be careful there, because and I say this from somebody who's done object mappers on top of Cassandra. I've tried it twice now. I tried it as an EJB, full-blown EJB QL implementation. And once you start getting into a situation where you want to do like a collection container reference, like company.employees.firstname stuff, that's really not going to work, and it's going to fall down pretty bad if you don't design that way. You really want to do, it's okay for, ORM would be okay for simple persist and load. You do not want to use it as query generation. You're going to get yourself into trouble. And with that in mind, talk about data modeling. So with that, who's in the room, either whether you have a project out there or not, who's done some data modeling with Cassandra already, that kind of work? Okay, so a good amount of people. This is a topic unto itself, and as much as I love the subject, I really, if anybody has data modeling questions, I'm happy to answer them afterwards. Grab me in the hallway or something. But it's totally out of scope of this, like, is really a bit unto itself. I will say this in the context of this presentation, though, is that it's really hard. You got to do research. Look around. There's a lot of good presentations out there. I would check on YouTube specifically, Google DataStax and Patrick McFadden. He's got some great presentations up there. He's doing one in the next set here after lunch called was it Real Data Models of Silicon Valley or something like that. But he does good presentations. He's really good at explaining data modeling in the context of like problems that you might see in real life. And data modeling always ends up to be the #1 performance problem. And part of me wants to be a little hesitant about bringing it up because I make a lot of my money there. It always turns out to be it's slow, or GC death it comes back to the data model, and the data model is just not right. And the main tip there, and the main takeaway is don't port your SQL schema. Just like, it's not something you can go like this. It's really, Billy talked about it. He used some great terms in the keynote there, is that you got to think about it now in the context of like being unconstrained with relations and thinking more about time. And it's really a chance to sort of step back and examine your like schema from a whole different perspective, architecturally. So I'd encourage you to take some time there. So moving on to developer productivity, to talk about language, and we're going to go through some of the techniques. UCQL, this is coming from a long time Thrift diehard. I wrote and maintained Hector for a number of years, and it sort of saddens my heart to say this, but like, Thrift is deprecated. There's still, there's places where it makes sense. I'm really interested in the work that the Netflix folks have been doing at Astyonics with the hybrid driver. There's still sort of a narrow band of use cases there where I think it's a good approach. It really sort of shines in truly dynamic column family models. But if this is your first project, I would encourage you to start with CQL and then as you get more comfortable with the sort of Cassandra at runtime, then investigate other things. PostgreSQL is great tool support. It's easy tracing and trace discovery, and documentation is great. A lot of people don't realize the actual documentation is maintained in tree. Links there on the bottom is their actual text, LaTeX files. So you can go check them out. They're maintained lockstep with the source code, so it's always in sync. That's one of the best things they could have done from a reference perspective. Use a Java driver from DataStax. It's not just like the vendor-supported thing. It's another thing. I've been on commits list and user list for a while. This has grown to be a really good piece of software, just from a perspective, from a professional perspective. It's one of those things I wouldn't have said that a year ago, 18 months ago. But I've become really impressed with this project as a piece of software, and I reference it in this presentation a bunch of times as best practice and good use cases. It's well written, it's well tested, it's got some good features in there, and the people on there are responsive, and there's a good community around it. It's a good piece of software. So there's no reason not to use it at this point. We talked about some of that. It's also open source. I'd encourage you to crawl through it and just look at the source code about how sort of patterns used in writing against Cassandra. Integration testing doesn't go as deep as you'd want coming from the perspective of an applications developer, so you have to look other places for that and play around with that a bit, but you can crawl through it and see how things are written, which is a good part of that. How many folks here are Spring Framework users? Okay, a good number. Take a look at Spring Data. They just did a release based on the DataStax release, and there's a CQL template in there that is going to be really, really, really familiar to you if you're used to JDBC template. That pattern would be a very good first approach to dealing with Cassandra, since everything is the same sort of template method callback handlers you're going to be used to, row results, things like that. It's going to feel familiar to you, and it's going to be a good sort of jumping off point. I don't know about you, but the last project I did got way into the weeds on Hibernate, and the last relational database project I did, and it got to the point where it was just so convoluted we had to pull stuff out and put in a JVC template. And I talk about this some other time. But any Juice users here? Wow, there's not that many. I've really come to like this configuration framework. But so in the UserGrid project, Apache UserGrid, we actually hit on a different way to do this with Netflix's Archaeus for configuration management. Are there other people here using Netflix open source projects in their code? Okay, just a few. I would really, really, really highly recommend you use Archaeus or take a look at it. It's configuration management. It does like dynamic property typing, dynamic property loading. It'll actually trickle changes to properties out to listeners. You can say the database connection pool reloaded. What do I need to do? Though I need to know about that, so I'll reload too. And in UserGrid, we built this into, we moved everything to Juice, and we built this into a project called JuicyFig that does configurations. If you're into Juice, take a look at it. Otherwise, configuration is similar to other DB drivers with a few caveats. There's some good documentation on a DataStax site, so I didn't feel the need to repeat any of the code on there. Take a look at it. The major difference is it's cluster. You aren't just dealing with a single thing or a single master slave. There's a cluster of nodes that have the same role. There's no special case. So there's two groups of configurations. There's policies and there's connections. Policy settings to manage behavior of the cluster, and connections are more what you would see from a JDBC pool, like connection count, that type of thing. Policy types, there's a load balancing connection and retry. The load balancing is what sort of policy you want to take, because in a situation with cluster, you can do simple round robin, or there's the idea of the clients having knowledge of the cluster topology to know that a specific key lives on a specific server. And that's called token-aware load balancing. You want to go back and read one of the original papers around Cassandra from, it's called the Amazon Dynamo paper. They describe this as client-mediated selects, which means that the client has the ability to pick the node in a cluster that holds the data, so you avoid the trip through the coordinator to get to the data. It's a good optimization to skip out a network round trip. And that is a wrapping policy. The token-aware load balancing policy can wrap like a round-robin policy, or It can wrap the data center aware round robin policy, so you have a knowledge of, I want to keep my reads in this data center, and I want to do token aware reads on top of the reads in this data center. So it's pretty well constructed in that things can wrap each other, and it's a good setup. Most people just choose token aware policy on top of round robin or on top of DC aware round robin if they're doing multiple data centers. The reconnection policy exposes exposes how to connect to dead nodes. Do you want to retry constantly to try to connect to a node? Do you want to do exponential back off? There's not really much going on there. And the retry policy is on there, and I see that as a lot of times that could be anti-pattern. What you do is you say that I'm not sure if this request was successful. I got like a timeout exception or unavailable exception. You leave it to the driver in the configuration phase to retry that request, and that's an excellent way to DOS your server if you get into a load spike. I've seen that go horribly wrong a lot of times. That's something you want to put up in the application logic for specific methods to given the business case, to catch those exceptions, the unavailable exception or timed out exception as they come back, and then do some decision up here as opposed to delegating that to the driver. However, there are some conditions where you want to delegate like a write maybe to a driver or something to the driver to say, keep retrying this write until I know I got it. There's reasons to do that at driver level. I would encourage you to stay away from it until you really felt like you were comfortable with knowing why exactly you're picking it. But then there's also a couple of wrapping policies in there. There's a logging policy in there. It's just like a fail-through logging policy. It'll log when stuff happens. And don't forget, you also have speculative retry on the server now. So some of that is moot as well. The connection options are really with the protocol. Also, the protocol is maintained in tree, the specification itself. So if you want to read about how the bits are set up on the wire, the headers and everything, you can do that. Also maintain the lockstep with the releases. Really the only thing in the protocol level is like, do you want to use encryption, enable snappy compression if you have a lot of text data. If you're shooting a lot of binary data in there, it's probably, maybe not. Most of the time you want to enable it. The pooling options are some of the most sane defaults that you could have in sort of using channeled I/O because it's using netty under the hood. So I would avoid not messing with those unless you felt really comfortable with how like evented I/O worked and how netty worked particularly, or you had something really specific requirements, the amount of processors on a box you're using, or you had your app was running a container, and you had a specific set of resources available. And the socket options, the same sort of thing. These are just lightly wrap the java.net.socket. Don't mess with those unless you're prepared to start tuning kernel parameters, particularly to buffer sizing, which if you're comfortable with messing around in proc, then you can do that. But if you don't want to do that, stay away from it. The defaults are just fine. On the application side, it's time to really embrace asynchronicity, right? But you're going to want to the driver can do asynchronous calls. It's all channeled I/O again on top of netty. But you're really going to use something like Rx.Java. And I put together a slide or two that had some code on there, but you can't not make that look ugly, even with something like Rx.Java. So I put the wiki link on there, and they have some great examples on their website about how to use this. And it's a good project that can wrap futures and turn them into observables the way you'd see with like a reactive design pattern that you see with JavaScript. It sort of exposes that in a way that makes sense to Java. And so I would really recommend you can do that because taking advantage of the asynchronicity of the driver can have some real performance benefits. Particularly if you want to integrate something like, Hystrix, the Netflix project that does a circuit breaker design pattern. So you can say that, I'm going to do these requests asynchronously, and if this thing fails, then I'm going to take these actions based on that failure in an asynchronous way so the rest of the application can continue. There's some good stuff to be done there in terms of like designing your architecture to take account of that from the start. So another interesting feature that's come up is user-defined types. I was really excited about these when I was looking into the driver. The driver has some excellent functionality around here. It's got some annotations and some really sort of good lightweight usages of those to stick your types or arbitrary objects into a user-defined type on the Cassandra side, it can actually sniff the UTDs from Cassandra as metadata back out to your driver. But I would say to hold off on it because, and it was alluded to this morning, and it's actually, they're serialized as blobs, regardless of size of the object. There's a really big issue with that. While individual property updates, if you're trying to update individual property, you have to update the entire object, and that can get you into some serious race conditions in eventually consistent system. If you have any sort of high velocity access at all to that object, and it can lead to performance degradation depending on the size of that object. So unless you're doing something trivially sized, I would say just to stay away from it until they refactor it. And 7423 there on the bottom is already open. They're already discussing refactoring. So that's what you saw with the frozen keyword this morning. I don't know if anybody caught that, but that's going to be the way they switch with the refactor. Try it if you want, but make sure your objects are very small and it's not something you're going to be updating individual properties on. Then they'll work great, and there's great driver support. Otherwise, it might be a painful migration path. Tools, the DataStax DevCenter, the sort of the CQL tool is just, it's one of those things that, I never thought I'd say this a couple months ago, but I use it almost every day now. It's really super handy for writing CQL and getting data, the metadata automatically out of the database and saying, here's a way you stub out these queries, just do this. And it's a really useful tool. I'd recommend everybody use that. My only gripe with it, the UI is great, it works great. My only gripe with it is that it's embedded in the download. So it's for DataStax Enterprise, so it's 600 megs or whatever. But you can deselect everything else if you don't want to do that. You can try it out. The rest of the stuff is pretty cool too. But if you just want I just want the CQL editor, you can just deselect everything else and just install that. But you still have to download the whole package. Metrics API. Heavily used in Cassandra now as of version 1.2. I would highly recommend you use this in your own code. How many people here instrument their code? All right, if you don't do that, I would recommend you sort of go back and do that, and then beg your management to get time to do that, because this will save you more than anything else. And if you take nothing else away from this presentation, know that the ability to instrument your code in such a way that it will be in lockstep with the statistical aggregations of your database will provide no end of value to you as you attempt to diagnose issues across the clusters. In a distributed system, this becomes a very big deal very quickly. Building up historical information on your behavior of both your application using the same timescales as the database, it becomes immediately clear when you need to add capacity. It becomes immediately clear when a release caused an issue, and you can see that. And the top link there is a link to column family metrics, everything in the metrics package, and org Apache Cassandra metrics is an excellent place to start and see how that API is used. And the metrics API is linked there on the bottom. So putting those two together, and then run something like Riemann locally to look at your own code. It's a really lightweight, real-time monitoring process. So you can have, and doing this will make you comfortable with how the behavior of the application feels, what it should look like when data is going into it, what latencies are. It's a sample dashboard, for a small 3-node cluster running locally. The write latency, read latency, and then the average latency over 10 seconds. And just having this in the background there running as a lightweight Java process. This is just Cassandra, but then running your own code in on top of this to do this graph aggregations to see, oh, that service I just wrote looks kind of weird when I hit that with more than a couple of requests. What's going on there? And I can't tell you how valuable this will be. And just getting an idea for what things should look like, and then seeing that in staging, and then seeing that in production, because you'll have the framework there that can just kind of follow that through. You'll know how to set that stuff up, and this is just, can be the most valuable part of your architecture. Chris Lofink from Pythian is doing a presentation later today called Monitor Everything. If you're one of those people that didn't raise your hand about instrumentation, I really suggest you go to that. He'll discuss in detail about how important that can be and sort of give you some good visualizations about what you can see with your architecture. with that. And unfortunately, at the same time, Chris McHenry, a good friend of mine from Sony, is doing Cassandra performance via histograms. So, I don't know who scheduled the 2 monitoring talks at the same time, but if you're already monitoring stuff and you want to know more about what you're looking at, go see Chris's. If you're not monitoring stuff, go see Chris McHenry's. If you're not monitoring stuff yet, go see Chris Lofink's. So, but go see one of those two because they're super valuable. Trace. Trace means a decent amount of data. There's tracing facilities built in to Cassandra at this point. Either by hand or by code. You can trace per query via SQL shell. It looks like this. Tracing on, now tracing requests. You put your query in there. It gives you a result right away. It gives you a session ID. Then it tells you what it's doing. You know, I spent some time preparing a statement. I'm enqueuing the message around to the rest of the cluster. I received the message, and oh, I have the data locally, so I'm going to run it there. Acquiring references to SS tables, you know, merging in the tombstones. And now, since the request can be satisfied locally, I start to read locally and read off the SS tables. And merging data from the mem tables to the SS tables. Okay, cool. There's the results. That's how long it took. But wait. There's a pretty big order of magnitude increase in sort of the time spent there. That's interesting. And so we look at that, and we see something like read 1 live and 2,677 tombstone cells. That's probably indicative that I did something wrong with my data model, or that I've chosen the wrong compaction strategy. There's some actionable information there, and I just didn't have to do anything complex outside of turning tracing on. Just like explain back in DB land or DBS land. You can do this through a driver, and there's an excellent example on DataStax's website about how to turn on tracing. There's a class in there called Query Trace that is a sort of an asynchronous handler for getting traces back from a query. You can do set trace probability via node tool, which is sort of the probability that 1 out of every X requests will be traced that are going through the system. And this it's a good way just to get a baseline of what's going on a node. Then with all this in place, make sure you do it again with the node down. And again, see what happens, because you want to get that operational experience. 10 minutes, man, a lot of stuff left. All right, let me move a little bit faster here. You want to get that operational experience as well as doing it right of what it looks like when stuff's in a failure scenario. Final node on tracing, do it sparingly. At the end of the day, it goes into the CQL table in a system. So you turn on trace for all the things, you will melt everything. Logging verbosity can be changed dynamically. Not a lot of people realize this. It's one of those things that has been there since version 04 RC1. This was actually on the feature checkbox for me in 2009 when I picked Cassandra for the first time. You can change it via JConsole. You can update the config, and the change will be picked up automatically in 30 seconds by default, I think. You can do node tool set log level and get log level in 2.1. That's a new feature in 2.1. It's super cool. And the way you can do the logging is additive, of course, like it is in the log4j. Turn on logging for storage proxy class in particular. You can see exactly what's coming into Cassandra data-wise and see exactly what is happening. So it's another level of actionable information you can get. Really understand node tool as a developer. You should understand 3 things, if nothing else: cfstats, cfhistograms, and proxyhistograms. Cfstats is per table statistics about size and performance. It's the single most useful command. If you learn nothing else, just make sure you understand that. Run it in development, run it in staging, run it in production. Just see what's going on. Cfhistograms is column count and partition size versus latency distribution. Another super handy one to understand. Proxy histograms is performance of inter-cluster requests as they're coordinating around a cluster. So you can see how things are being handed off and how sort of responsive they are and where lags are and find hotspots. So running Cassandra during development. Local Cassandra is an option. It's easy to set up. You control it. But then the downside is that you control it. It's going to get out of date. CCM is an excellent tool. Sylvain, one of DataStax developers, longtime Cassandra contributor, uses this as a Python wrapper that just does multiple Java processes on the same machine. and uses 127 local addresses and manages supports to avoid collision. I've become a big fan of Vagrant recently because you can really do isolated, controlled environmental stuff. Configuration management can be integrated. If you use Chef or Puppet, that's just plug and go. You know, it's use the same CM you do for production, configuration management you do for production, and then you're testing your configuration management system. You can do a Vagrant file that looks like this. You know, I want 3 servers. I start with a monotonically increasing 192 address. The first IP address is 10. For each server, I set up the node ID and the IP address and set the initial token based on that formula. And now I pump in through my Chef recipe, the initial token and the server IP address. The rest of that is a really tuned down test version that can run Cassandra in about 300 megs of instance size. You can get, 12 instances in a cluster on your laptop if you do it right. I definitely recommend experimenting with Vagrant for this very reason, because you can push this all the way through to environments. And that's you definitely encapsulate your environments. Configuration management is absolutely mission critical for a distributed system. You need to know exactly what everything is, and treating your code, your configuration as code is what you need to do. You should be able to go laptop to production with no manual modifications. If you're doing like, oh, so-and-so has this, and we add this connection string for my local thing or whatever, that's like, you're doing it wrong. I mean, you are. So, and that gets us into testing. All right, I know ahead of time, I'm not going to finish on time. The hardest part of this was taking content out. So I'm going to go through this pretty quick. Feel free to grab me afterwards if you want more information on any part of this. I have it for sure. So use a naming scheme, because right, we're dealing with an external system. This is a distributed system. The ramp-up time is going to be a lot slower to set up test data, to start a cluster, et cetera, et cetera. So you do things like unit tests, no external resources. I-test, it's an external resource. PI-test, it's a parallel. You can make a parallel external test. Wildcards on CLI are not a naming scheme. Don't do that. Just do it right. Group tests and logical units, suites, JUnit calls them. I don't remember the name TestNG uses, something like, I think it might be suites as well. But this gives you the ability to, say, share test data, share Cassandra instances, and do like build profiles to say, I only want to run the short unit tests. I want to run the transactional unit tests. I want to run the whole test suite, the long unit tests, include everything. Here's an example of that, really quick. This is the short. This is from the DataStax Java driver, by the way. These are the short unit tests. They use unit and short annotation. Use them in a code. There's ties back to short annotation, so that I'm only running the tests that I know take a short amount of time to execute, versus a test where I need to load that 2 gigabit data set into my cluster. So that's an excellent way to speed up build time for your developers, because this is one of those things that will sneak up on you as if you're managing a team, that all of a sudden people are like, it took like 50 seconds instead of 20 seconds to do the build, and somebody's just sitting there like, that's not really enough time to do something else, but that adds up into hours a month when you're just sitting there. So if you can parallelize this, you will see immediate, it's one of those things, it's like one of those hidden like productivity gains. It's like, whoa. Use mocks wherever possible. That goes without saying, but again, when you're mocking something that can be an external resource that's a distributed system, like you just need to do it, or to speed up time. Unit versus integrate. Any Maven users here? Who really knows the difference between Surefire and failsafe? Like 2 people, yeah. It'd be hard to tell because the websites are almost identical, but they do different things. So, but be pragmatic. Do what you need to do for the size of your team. But one's for integration testing, the other's for unit testing. Verify assumptions and test your failure scenarios explicitly. You got to get in a situation where you turn a node off and see what happens with your integration test as that node is down, or else you will be surprised by things. And that gets us into runtime integrations. There's sort of 3 ways you could do it. There's local, there's in process, and there's fork process. Local would be like just like running a Cassandra on your desktop, and that's just like don't do that. That's tacky, really. And like embedded Cassandra is like in process, where you have the same JVM handling test cases has a Cassandra instance, and like that works. That's great. If you have a small project, do that, but that can get into collisions with test data really easily. The best thing to do is what a couple different tools out there will do with process builders to fork Cassandra. The Cassandra driver, the DataStax driver has an excellent class in there that you can take and use in your own code called CCM-Bridge that does this out of the box. You can say I want 1, 2, 3 end nodes. I want 3 nodes and 2 different data centers, and the CCM-Bridge passes that down to CCM as command line parameters. You could do the same thing with Vagrant if you knew how to set it up to delegate down the CLI. But just the takeaway here is the best practice is that Jenkins should be able to manage your cluster, or Travis, or whatever your build tool you use. All right, I'm getting a sign to wrap up already. Jeez. All right. Vagrant versus CCM-Bridge, choice of style. I have a couple things in here about load testing. You want reproducible metrics. You want to catch regressions. You want to test breakage points. Use stress.java. There's been a lot of changes recently. It's a great tool. Cassandra JMeter from the folks at Netflix is a really good tool. Workload recording and playback is coming soon. That will be out in 2.1.1. That looks kind of interesting. I'm curious to see what there is. The primary testing goal is to not let your cluster behavior surprise you. You really can't emphasize enough how much you want to know what those failure scenarios are as you go into production. Some summary: go slow, bite-sized chunks, segment your test case, use build profiles, monitor. Like I can't say that enough. Use reference implementation drivers, control your environments, and then verify your assumptions about failures. Thanks.